Okay students, in chemical kinetics we have discussed about the rate constant, how to write the reaction, how to write the rate law and its expression. Then we have discussed about the zero order reaction, first order reaction and its unit. Now today we discuss about the zero order reaction and integrated rate equation for zero order reaction. Suppose for a particular zero order reaction, reactant is converted to product. Zero order means reaction does not depend upon the concentration of reactant. You take the reactant of any concentration, but order of the reaction is zero. So if you take 1 molar, 2 molar, 3 molar, then rate of the reaction does not alter. Rate of the reaction we written in terms of reactant, then it is minus dr by dt. Why minus? Because reactant concentration is decreases during reaction. In terms of product, then it will be plus. So minus dr by dt pertain to reactant and pertain to time. That is the rate. But this rate is directly proportional to zero power of the concentration of the reactant. Why? Because it is zero order reaction. Therefore is equal to K, that is equilibrium constant, R raised to 0 power. So this R raised to 0 means it is equal to 1. Also R raised to 0, that is equal to 1. It will cancel. Any number raised to 0 then 1. So minus dr by dt is equal to K. dt you take on other side, then minus dr by dr is equal to K dt. Therefore minus take on another side, then dr is equal to minus K dt. So that is equation number 1. This equation on integration, equation number 1 on integrating, it is converted into R is equal to dr turns to, on integration turns to R is equal to minus Kt plus I, that is integration constant. So R is equal to minus Kt plus I, where I is equal to integration. This equation is nothing but it is of the straight line. Y is equal to mx plus c. Okay, y is equal to mx plus c. Remember this equation. If you plot the graph of reactance against time, R reactant against time interval, then it will give the straight line. Okay, it decreasing slope is 3 point, you take it, then graph is like this, its slope, if you measure the slope of this equation, then it will gives m is the slope, so it is minus k. Slope is equal to minus k, and this intercept is equal to r0 at time interval t is equal to 0, r is equal to r0. So graphically we can measure the initial concentration of the reactor. Suppose for this, again we revise this equation number, this equation, okay, integration, we find this I value from this, then at time t is equal to 0 means initially, then r is equal to r0. At t is equal to 0, r is equal to this, you put it in this equation. So for that t is equal to 0, then whole this value will come 0 and r is equal to r0. This value comes to 0, so that is directly proportional to I, that is integration constant. This I value you put it in this equation number 2. I is equal to R0, then this equation number 2 turns to R is equal to minus Kt plus R0. This is concentration, so you write in bracket. A square bracket, then it is concentration. So that is R0. Kt you take it on another side, then Kt is equal to R0 minus R. If you remove this T and take it on other side, then it is divided by T. So this equation K is equal to R0 minus R by T. That is the integrated rate equation for zero order reaction. So that is equation number 3rd. Okay, so we have derived for zero order reaction equilibrium constant K is equal to R0 minus R, means initial concentration minus concentration at particular interval divided by time. This time is in second. Then we can get the rate constant for that particular reaction. Now we derive T half for this reaction. T half. Get T half for zero order reaction. T half. T half is the time required. T half is the time required for the reactant to become half of its initial concentration. That is known as half time period. Half time period, that is the time required for half of the initial concentration. Means if T is equal to T half, then R is equal to R0 by 2. Its concentration becomes half of the initial concentration. So here this value you put it here in main equation, that is K is equal to R0 by R upon T. This thing you put it here. Then T half you take it on this side. Instead of T you write T half. T half is equal to K till comes R0 remains as it is. R you can write R0 by 2. You take the LCM. Then here it will come 2R0 minus R. So this value comes and this 2 will come down. So it is R0 by 2K. So T half for zero order reaction is equal to R0 by 2K. Again I repeat, T half is equal to R0 by 2K. Means it depends upon the initial concentration and directly proportional to initial concentration and inversely proportional to rate constant, that is equilibrium constant K. So two things we have derived. This is equation number 3 and you think this is equation number 4. That is for zero order integrated reaction. Try to solve the intact sum related with zero order reaction. Okay. K value and T half value. This derivation is important and its example as given in your, that is very important. Okay, thank you.